State the principle of conservation of momentum. What is meant by the terms elastic collision and inelastic collision? So starting with this one, principle of conservation of momentum says the total momentum before impact is equal to the total momentum after impact. And what is meant by elastic collision and inelastic collision? Elastic collision is a collision in which both kinetic energy and momentum is conserved. Inelastic collision is a collision in which only momentum is conserved but kinetic energy is not conserved. A 1 kg object traveling at 1 meter per second collides head on with a 2 kg object initially at rest. So what we have is, let me use a ball. This one is 1 kg, which gets to move at 1 meter per second, and it hits something that is at rest, and it has got a mass of 2 kg. Now it is head on, meaning that they hit themselves like that. So meaning that even the bouncing, they are going to be bouncing. One will go forward, one will go behind, something like that. That's the head on. Okay, like it's not like a billiard where one is pushed in that direction, one like that. Okay, so what? Find the velocity of each object after impact if the collision is elastic. Now, since this is elastic collision, meaning that kinetic energy is also going to be conserved. So we're going to say from conservation of momentum, m1 u1 plus m2 u2 is going to be equal to m1 v1 plus m2 v2. So m1 mass 1 is 1 kg, the velocity is 1, mass 2 is at rest, so the momentum is 0. m1 final is still 1, we don't know the velocity, and then m2 is 2, we don't know the velocity. So this is going to be 1 is equal to v1 plus 2 v2. So this is going to be equation 1. Now, since this is elastic collision, from the conservation of momentum, we know that u1 plus v1 is supposed to be equal to u2 plus v2. u1 initial velocity 1 is 1. Final velocity 1 we don't know. Initial velocity 2 is 0. Final velocity 2 we don't know. So I can make v1 substitute the formula. So v1 is going to be v2 minus 1 is equation 2. I can also make v1 substitute the formula. So v1 is actually going to be equal to 1 minus 2 v2. So both are v1s, I'm going to equate them. So v2 minus 1 is going to be equal to 1 minus 2 v2. So this is going to be v2. If I take this one the other side, that is going to give us 3 v2. I take one the other side, that is going to be 2. And that v2 is going to be 2 over 3. And that is 0.66 meters per second. And then to find v1, we can use n1 of these two. v1 is equal to 1 minus 2 v2, which is 0.666. Okay, so 0.66 times 2, then 1 minus answer. That is going to give us v1 being equal to negative 0.33 meters per second. So meaning that v1 bounced back. That's why the velocity is negative, because we're taking motion going forward as a positive. Is that okay?
Yes.
Okay, for B, suppose the collision in A was perfectly inelastic. So because it was perfectly inelastic, meaning that these two balls had to stick, or these two objects has to stick. So meaning that they are moving at the same velocity and they've got a combined mass, so their mass will now be 3 kg. We want now to find the velocity, find the velocity of the object after impact. Okay, velocity of the object after impact. So from conservation of momentum, again, m1 u1 plus m2 u2 is going to be, now they've got a combined mass and a combined velocity. m1 is 1, velocity is 1, the other one is at rest. So to be able to find this v, we just get to divide 1 by 3, and that is going to give us 0.33 meters per second as the final velocity for both. Okay, so that will be for the velocity of the object after impact, and then to the fraction of the kinetic energy lost during the collision. Now we know that kinetic energy is going to be lost, but energy is actually not lost. It's just converted to other forms. So I can say the loss in energy is the final energy minus the initial energy. Okay? Or I can say energy before impact should be equal to energy after impact, like that. So energy initial is equal to energy final. Now initial energy, both one object is moving, meaning that it has got kinetic energy. So kinetic energy of the first ball, the other one doesn't have any energy, is going to be equal to, since they stick, is now going to be equal to the kinetic energy of both 1 and 2, because they get to combine. So it is only K1 which is going to bring its energy. Now because not all this energy is going to be converted, there is some loss, so plus the loss. Okay, so the kinetic energy of this one is going to be the kinetic energy at the end plus that same loss, because if you get to add the loss plus the final kinetic energy, it should give us the initial kinetic energy, or the initial total energy, because initially the total energy is just kinetic. So this is going to be half kinetic energy is half mv squared. The mass of the ball that is moving is 1, its velocity is 1 squared, and that will be equal to half the mass is the combined mass, which is 3, their velocity 0.33 squared, then plus the loss. So this is going to be 1 this side, and that will be 0.33 squared times 3 divided by 2. It is going to be 0.166 and plus loss. Therefore the loss is going to be, I'll take the 0.166 the other side, so that will be 1 minus 0.166, that is going to be 0.833 joules. That is the loss in energy. Now I want the fraction. So fraction of the energy which was lost is the energy lost, that is 0.833, divided by the energy which was available initially, that is 1, that's the initial energy. If we want, we can multiply by 100 since it's a fraction. Okay, so meaning that is just 0.833, that is it, or 83.3% of energy was lost. Is that okay?
Yes.
Okay. Question 2. A billion ball moving at 5 meters per second strikes a stationary ball of the same mass. After the collision, the first ball bounces at 4.33 meters per second at an angle. Okay, so we have got this billion ball. It has got a mass of it is moving at a velocity of 5 meters per second. It strikes another one which is at rest of the same mass. So if this one is m, even this one the mass is m, and then at the end of it all, like that, at the first ball moves with that speed at an angle of 30 degrees, so it gets to bounce up at 30 degrees. Okay, with respect to the horizontal, and then it moves at 4.33 meters per second. Assuming an elastic collision and ignoring friction and rotation, find the track ball's velocity. Find the track ball's velocity, that is basically the velocity of the other ball, and basically also the direction of the other ball. We know that it's supposed to go in the opposite direction, that we know. So let me call it as v, that will be the direction, and then the angle down is going to be just theta. So we need to work this in components. So starting in the x component, the initial velocity, that is m1 u1 plus m2 u2 is going to be equal to m1 v1 plus m2 v2. So m1, the masses are the same, so I'll just say m. Now v is 5 for the first ball, and then plus m2, it was a trace, so this is 0, and that will be equal to m1, that is 5. Sorry, m is, we don't know the m here, that is just m. And then v1, now remember this is index, so we need to find the x component of this velocity for the first ball, which is in yellow. That is actually 4.33 cosine the angle, which is 30, and then plus m2, that is going to be just m. Now v2 I don't know, so let me just say vx, because this is velocity in the x that we are talking about, the x component of the velocity for 2. So give us 5m being equal to, get to punch, 4.33 cos 30, and that is going to be 3.74988 m, and then plus mvx. So the m is common throughout, it gets to cancel. So I'm going to take this term, the other side is going to subtract, so we are going to remain with vx. So vx therefore is going to be 5 minus answer minus just 3.7, and that is going to give us 1.25011. This is in meters per second. And then we go in the y. So in the y also, conservation of momentum, m1 u1 plus m2 u2 is going to be equal to m1 v1 plus m2 v2. Now m1, this thing wasn't moving in the y, meaning that the momentum in the y is 0. The other one was also at rest, it was 0. Now m2, m is m, m1 is just m because that's a mass. v1 now in the y is going to be v, which is 4.33, but sine of 30, and then plus m, I'll just say vy. Okay, so this is a 0 this side. I'm going to take the mvy the other side to be negative mvy, and that will be equal to, now we punch 4.33 sin 30, and that is 2.165 m. So the m cancels out, so vy is therefore going to be negative 2.165 meters per second square. And this makes sense, because if going up is actually positive, then going down you're supposed to get a value for y being negative. Okay, but in the x, both components for this one and for this one are positive because they are going in the same direction. Now that we have found the components of the velocity, we can find the velocity at which this one is going to be moving. So v is actually going to be square root of vx plus vy, that is 1.25 squared plus negative 2.165 squared. So that is going to give us velocity being equal to, have I punched the right thing here? Okay, just give me a moment. That is 1 point, okay, let me repunch my answer. We have got 1.25 squared plus negative 2.165 also squared, and then we square root the answer. So that is 2.4999 meters per second. So that is the velocity. Also need to find the direction. Theta is given as tan inverse of y component over x component. So be tan inverse Y component is negative 2.165, X component is 1.25. So tan inverse of a negative 2.165 divided by 1.25, this is giving me negative 60 degrees. Now the negative just means that we know that when you are measuring angles, you always go in the anti-clockwise direction. So if you go in the clockwise, that's why you are getting the value as negative. So that is it for this question. Okay. Now also have this one. A bullet of mass 15 grams and traveling at a speed of 4. We can make a sketch of that. So this has got 15 grams and it is traveling at 600 meters per second, strikes a block of mass 3 kg which suspends by a string. So we have got a string somewhere here and then a block here. Okay, a block of 3 kg which suspends by a string of length 4 meters. The bullet goes through the block in a very short time and the center of mass of the block is found to rise a vertical distance of 10 centimeters as shown. So what happens is this thing gets to move like that, and this thing gets to rise for a certain height h, which is given as 10 centimeters. What was the speed of the bullet just after emerging through the bullet? So the bullet actually moved, it passed through here and then it came out. So using conservation of momentum again, m1 u1 plus m2 u2 is going to be equal to m1 v1 plus m2 v2. So initially what is going to happen is that uh, you have got a bullet that is going to go inside this block. So it is having a mass of 15 grams. Now we need to convert to the right unit. So 15 divide that by 1000, it is actually 0.015, multiplied by the initial velocity that is 600. Okay, and then plus, now this block here is at rest. Okay, it is at rest, meaning that it has got a velocity of 0, and that will be equal to m1 mass 1 is still 0.015. You don't know the velocity at which is going to come out, and then plus mass 2, the mass is 3. You still don't know the velocity at which is going to be moving going in this direction just after impact, so we are going to call that as v2. So 0.015 times 600, that is going to give us a 9, and that is going to be 0.015 v1 plus 3 v2. We should be able to find v2, the velocity of the bullet at this position. How can you find? Because by the time the bullet is coming out, it is still at this position. It's still not moving, but it's going to have a velocity. So at this point, this thing has got potential energy. So it's going to gain kinetic energy when it is hit by the bullet, and that is what gets to make it rise to this position, and it is going to only have kinetic energy there. So potential energy on the bottom is equal to kinetic energy on top, and this is mgh is equal to half mv squared. So the masses cancel out. So what we have is v is going to be square root of 2gh, and this is going to give us square root of 2 multiplied by 9.8, and the height which was moved is 10 centimeters, which is 0.1 meters. Square root of 2 multiplied by 9.8 multiplied by 0.1, it is going to give us 1.4 meters per second. That is the velocity at this position, because at this position it has got it's actually going to, it has reached a point where it's no longer moving, it wants to come back. So here the velocity is 0. So I should have said kinetic energy on the bottom is equal to potential energy on top, because it has only potential energy, something like that. ah, I've again swapped. So on top it actually has yeah, the potential energy that it has here gaining kinetic energy. So the potential energy is all being converted into kinetic energy. By the time it reaches the very top there, it's no longer moving. Okay, so it has got a certain speed at this position, and that speed is being converted like that, and until it becomes zero. So potential energy there is going to be kinetic energy on top. Is everything is being converted. So here now say 9 is going to be equal to 0.015 v1. This is the initial speed. That's a speed before it was hit by the bullet. When it was, now this v1 here, it's the speed of the bullet after it merges out. Now I want v2, which is the speed of the block when it is hit. So before it was hit by the bullet, it wasn't moving, but immediately it was hit by the bullet, it started moving, and this is the speed at which it is moving. So meaning that it has got actually kinetic energy here, and then on top here it has got potential energy. Okay, on top this as potential energy, it's no longer moving, that's why it has got potential energy. So the velocity is 1.4. So I'll take this term the other side. So I'm going to have 0.000.015 v1. That is going to be 9. First I'll multiply 1.4 times the 3. It is going to give us 4.2. So 9 minus 4.2 to give us 4.8. So to remain with v1 now, velocity with which the bullet is going to merge with, that is going to be 4.8 divided by 0.015. That is going to be 320 meters per second. So this is the speed at which it measures, and as you can see it is smaller than the speed with which it was coming, because by penetrating through this block the speed would have been reduced.